Okay, so we are starting lesson 7, all, some, or no solutions. So in your lesson today, we're going to be talking about how many solutions an equation can have. So up to this point, our equations have had one solution. It was, x equals 5 or y equals negative 10. And today you're going to look at the possibility that an equation may have more solutions or none at all. So before we get there, let's take a look at section 7.1. Which one does not belong? So take a minute, look at the 4 equations that you see, and you need to choose which does not belong and why. So on your paper, circle the equation that you feel does not belong and write a sentence or two on your paper about why that does not belong. So push pause and do that. Okay, so head down to section 7.2, and we're going to take a look at some equations, and we've got to decide if the equation is true for all values or true for no values. Okay, so these are the two different categories that we're going to put these equation in. True for all values or true for no values. True for all values means like any number will work. True for no values means no numbers work. So you can pick any number and the equation will be true, or there are no numbers that will make the equation true. So there are many different ways that you can approach this. You can kind of mentally try to guess and check. But when the equation is pretty small, it's pretty easy to kind of guess and check in mental math, figure out which category this would belong in. Some equations you have to do a little work first, or it's more efficient to do a little work first. But let's take a look at our first equation here. So we'll call this number 1. N equals N. Now, usually we're used to seeing like N equals 20. And remember, our goal is to get variables on one side and numbers on the other. But if we look here, I have a variable on both sides and no numbers anywhere. And if you look at it, it literally says N equals N. So let's pick a number for N. Pretend that N is 3. Okay, so if N was 3 and I replaced it, would 3 equal 3? Yeah. What if N was 12? Well, 12 would equal 12. What about 3.7? So no matter what N I pick, the equation will work, right? So we're going to call this all values. Let's look at number 2. So number 2 isn't quite as obvious as number 1. So let's simplify a little bit. The left side, oops, let me make my T look like a T. Be careful with these variables when you get something like a T. Let me zoom in a little bit here. When you get something like a t, make sure that you can tell the difference between the t and the plus sign. So let's distribute my 2. So now I have 2t plus 6 equals 2t plus 6. So take a second and look at that and think about where you'd want to go from here, because we have to decide, is this a situation where any t we pick is going to work, or there are no t's possible? So take a second, and from what you see right here without doing anything else, see if you can make a prediction of which it'll be. Okay, so if you're unsure, we're going to solve this a little bit, but I want you to solve it with me a certain way. You'll see in a second. So I want to eliminate this 6 right here. So I'm going to subtract 6 from each side. And I get 2t equals 2t. Now, if you notice, it's very similar to what we had previously, n equals n. The same type of situation I have here, 2t equals 2t. So I'm going to multiply 2 by a number, and it's going to equal 2 times a number. Now, if we want to go a step further, let's divide each side by 2, because that will get me t. Look at that. That looks just like number 1. So that means this is all values. Now, something I want you to see, don't copy this down. And I'm going to actually write in the next box. So look over here for just a second, and don't write this down again, just look. Let's say you solved this. Let's say when you solve, you like to, move your variables first. So I'm just going to see what would have happened if instead of subtracting 6 from each side, I subtracted the 2t. I get 6 equals 6. Okay, the variable disappears, but if you notice, I have a number equaling itself. If I have a number equaling itself, that means all values will work. Just so you know, I know when you see this, it would look strange because the variable disappeared, but this is the same exact equation solved 2 different ways. So that means the solution still has to be the same, even if I choose a different way to solve, as long as I did my math right. So whether you get or a number equaling itself means all values work. Okay, I just wanted you to see that a different way. Okay. All right, let's go on to number 3. So for 3, we're going to go through the same type of process. Let's simplify. So I'm going to distribute this and become 3n plus 3 equals 3n plus 1. So take a second and see if you can predict, without solving, can you predict what is going to happen? Will we have all values equal or no values? Okay, well, let's start solving it. I'm going to solve like I did the last one, and I'm going to eliminate my numbers first. So let's say I want to get rid of this 3. So I'm going to subtract 3 on each side. So 1 plus -3 is -2. Okay, so if we look here, I have 3n equals 3n minus 2. So let's think about this for a minute. I have 3 times a number on the left. And it's going to be equal to 3 times a number, the same number, but then I'm subtracting 2. Seems a little weird. Okay, don't write this down, but imagine my n was 1. Okay, so if n was 1, 3 times 1 is 3. 3 times 1 is 3, but then I'm subtracting 2. Will 3 ever equal 1? No, that's strange. Let me keep solving and let's see what happens here. So if my constant is over on the right, let me get my variable to the left. So I'm going to get rid of this 3n. 3n minus 3n is 0. 3n minus 3n is 0 minus 2. Will 0 ever equal negative 2? No. If something ends up looking weird, like it does, it's not equal, there's no possible way that can happen, then that means no values will work. So if the left and the right don't equal each other and never will, that means no values. Okay, let's look at our last one on this row. Let's distribute. Oh, I take that back. Let's multiply each side by 4. You'll see why in a second. 4 times 1/4 gives me 20d plus 4. 4 times 5d gives me 20d. So take a second, see what you think here. If you can predict what's going to happen. Now, if I think about what happened previously, I'm going to get 20 times the number adding 4 is never going to equal 20 times the same number. But if we continue to solve, my variables are on the right side, so let me get rid of the variable on the left and move it over. I get 4 equals 20d minus 20d is 0. This is where you're really going to have to pay attention to what you're doing in the math here. 4 will never equal 0, so this is no values. Okay, oops, sorry. Uh-oh. Let me give you a second if you need to pause and copy this down. Let me move this back here. So copy that down if you have to. Okay, next one. Now, and your paper should look better than mine. Mine kind of got messed up here. But let's go ahead and simplify each side first. So on the left, 5 minus 9, you get negative 4 plus 3x equals, and we combine negative 10 plus 6. We get negative 4 plus 3x. So hit pause, take a second, compare this to what we saw happening on the top row, and see if you can determine what the values are, all values or no values. Well, if you said all values, you would be correct. So if you actually wanted to solve this down, you could solve it any way you want. Let's say you want to get rid of this 3x first. I would be left with negative 4 equals negative 4. Because this will always happen, it's all values. So if when you start solving down, if the left and the right is actually like literally equal to each other, that means all values. If the left and the right will never be equal to each other, it's no values. Okay, let's take a look at the next one. You have a couple options here. You could multiply each side by 6 to clear the fractions. But what I'm going to do is I'm going to solve this by eliminating this x. Go with me here. So x minus x is 0. If I subtract the left by minus x, I'm going to do minus x on the right. Or if I'm going to take away x on the left, I'm going to take away x on the right. So this cancels, and I'm left with 1/2 equals 1/3, and those x's cancel. 1/2 will never equal 1/3. If the left will never equal the right no matter what, no values. Next one. This is all multiplication. So I'm going to multiply these first, and I get 18y equals 2 times 9. Oh. Let me give this a second. There we go. 18y equals 18y, because the 2 times the 9. Now, I don't need to divide each side unless you want to, because if you look here, 18 times a number is always going to equal 18 times a number. The left side is literally the exact same thing as the right. So this is all values. And my last one, if you notice from the beginning, my v is the same on each side, but on the left I'm adding 2, and on the right I'm subtracting 2. If you have a number and you add 2, it's never going to equal a number minus 2. You're adding 2 to one and you're taking away 2 from the other. They'll never equal each other. So this should be a no values, but we're going to solve it anyway just to be sure. So you can solve it however you want, as long as you're using the correct math. I'm going to add 2 to both sides to eliminate this -2, and I get v plus 4 equals v. Adding 4 to v will never equal v. This is never going to happen. And if you want to go a step further, you could actually continue to solve this. I'm not going to, but if you wanted to continue solving and try to get variables on one side and numbers on the other, you're going to end up with 4 equals 0. This can never be true because adding 4 to a number will never equal itself. So this is no values. Now this is all we're going to do for today. So you're going to stop here, keep this paper because we're going to continue the second part tomorrow.